Hello, everyone. Thank you for joining us on this Wednesday afternoon. Today we are assembled here to talk to you about NoSQL for modern apps and AI, the future of Memorystore, Firestore, and Bigtable. Let's start with first the introduction of the presenters. My name is Vaibhav Govil. I'm the PM Director for Cloud Native Databases in Google, including Spanner, Bigtable, Firestore, and Memorystore. I'm joined here with Phaneendhar Vemuru, who is the Senior Director of Engineering for Firestore and Bigtable. And then finally, we have Chethana Savalgi. She is Director of Software Engineering from Palo Alto Networks. And Chethana is going to share a lot about how Palo Alto Networks are using our non-relational databases. So this is the agenda for the talk today. First, we are going to introduce non-relational databases to you, our portfolio of Google databases. Then we are going to talk to you about some of the new recent innovations. There's a lot of exciting stuff which Google has been doing in this non-relational database space. We are going to share those things with you. And then Chethana is going to talk to you about Palo Alto Networks' use of non-relational databases for some of the most mission-critical workloads on their end. So for those of you who have attended our database session previously at Next or this year itself, this slide may be mostly familiar. This is our portfolio of Google database services. You can see there's a healthy mix of relational, non-relational databases. On the non-relational side, we have Memorystore, which is a fully managed in-memory data store service. We support Redis, both standalone or a single shard Redis, as well as cluster mode. And then there's Savalgi, which is offered both in cluster mode disabled as well as cluster mode enabled, as well as Memcached. Then we have Bigtable, which is a very popular key value wide column database service. It has an age-based interface, as well as last year we launched Google SQL support in Bigtable. And we'll talk a lot more in detail around Bigtable and some of the innovations which we are doing in that space. And then we have Firestore, which is our serverless document database service. And as you can see, we now offer MongoDB compatible interface on Firestore as well for you to seamlessly be able to adopt Firestore with very limited application changes for your MongoDB workloads. And because this is an AI, it is an AI in working in conjunction with databases session, the way we like to think about AI is our databases serve as the bridge between your applications and foundational models. And in terms of AI capabilities, we think of it in like three categories. One is Gen AI, second one, agentic AI is all the rage. So there's a lot of development going on in databases on agentic AI. And third category is native AI capabilities within the databases itself. On the Gen AI front, ability to seamlessly connect with models which are hosted in Gemini Enterprise for agent platform, ability to generate those embeddings to use with your vector search capabilities. A lot of our database services support vector search. And things of those natures is something which we continue to develop on. In terms of agentic capabilities, our database services have managed MCP support. This is something which we recently announced. We have integration with Gemini Enterprise Agent Platform. And then in terms of the ecosystem, we continue to integrate with a lot of AI tools out there. For example, AI orchestration frameworks like LangChain and Llama Index, we are integrated with them. So let's talk more about Memorystore. So Memorystore is an extremely popular database service within GCP. In fact, 95% of our top 100 GCP customers are on Memorystore. In terms of performance, we are talking about microsecond latency. Millisecond is not good enough. We are talking an in-memory data store. And this is all offered at a very high availability with up to 4 nines availability, which Memorystore provides. And in terms of scale, we offer full range of scale for our customers. You can have a cache production grade for your micro workloads at 1.25 GB of in-memory storage, all the way up to multiple terabytes in size for a cluster offering like Memorystore for Redis cluster or Memorystore for Savalgi. So again, extremely flexible and scalable service. Now, one of the latest enhancements which has happened, and it was a very much of awaited capability from in-memory data store users, was the launch of Valky 9.0. For those who are not familiar with Valky, it is a Redis fork which was created and is supported very widely by a lot of the industry. And in terms of Valky 9.0, first and foremost, there are a lot of throughput improvements in there. For example, with Memorystore prefetch, memory free fetch, customers are able to get 40% more throughput. And in addition to that, if they are using zero copy responses, there's 20% additional throughput they are able to realize. These are all OSS metrics. So this is something which the community put out. And there's a blog post if you Google for it, and you can read for yourself. Some of the other enhancements include hash field expirations, a lot of reliability improvements. I'm personally very excited about atomic slot migration. This is something which Google themselves contributed in the community as well. So you are looking at atomic slot migration to have better reliability in case of cluster scaling and rebalancing, which is very critical. As we know, our customers are using in-memory data store and Memorystore for different kind of workloads, big or small. So we wanted to provide this optionality to our customers to have different node types to match and suit their needs based on the workload. So I'm super excited to announce 6 new additional node types in Memorystore. And these are, we think of them in these 3 areas. So for dev and micro workloads, we have 3 new node types, which allows you to have a single shard Memorystore for Valky or Memorystore for Redis implementation. As you can see, the amount of compute is the same, 2 vCPU, and you can go from 1.25 GB to 2.5 to 3.75 GB. And in fact, some of our customers who are looking to migrate from Memorystore for Redis standalone to Memorystore for Valky cluster mode disabled are already leveraging these 3 node types for some of their workloads. Now we are living in the AI age, and some of these AI workloads like feature stores and things like that, they are extremely compute intensive. So we are announcing 2 new node types which are for compute intensive AI kind of workloads. One is a high CPU medium with 8 vCPUs. The other one is the standard large, again with 8 vCPUs, providing that extra amount of compute for limited amount of data in a very cost optimal way for customers to use it. And then for really large scale in-memory data store use cases, we are announcing a XXL node type, which has a single node storage of 110 GB, which allows you to get up to 27.5 terabytes of a cache in a single cluster. Now, in addition to all the enhancements which we have done on the node side, we are also bringing in a lot of modules which the community has produced. One of them, like vector similarity search, is something Google contributed into Valky community. It's already GA. I'm thrilled to announce that JSON as well as the Bloom filter module are GA now in Memorystore for Valky, and customers are already using it for different workloads. Now, we can launch all the capabilities we want, all the features and everything, but ultimately, we need to enable our customers to migrate to Memorystore for Valky. And for that, we are announcing a native online migration capability in preview today. And in development of this native migration capability, we leverage our cross-region replication capability. You can simply connect to Memorystore for Valky as a secondary cluster. The primary one would be your self-managed Memorystore for Redis or Memorystore for Valky. And then once you connect, you can replicate your data, and you will do the cutover, and finally it will be a cleanup. This is all done automated on behalf of you, so it's a very seamless migration capability which we are providing for our customers. And the list of innovations doesn't stop here. Some of these I've already discussed, but we are also launching new security capabilities which a lot of customers have requested from us. For example, the flexible CA support. This is for CA management for our customers, and it also includes regional CA support, or customers can self-manage the CA. Then we have token-based authentication, or basic auth, as we like to call it. This is available for those customers who are using basic auth in their services. And soon enough, we will also be launching ACL support in Memorystore, and that will be coming soon. Now with this, I'd like to hand it over to Phani to talk to you about Bigtable and Firestore.
Thank you, Vaibhav. Hello, everyone. Thank you for coming during your lunchtime. We really appreciate it, and hope you take away something from our talk over here. I would like to start off with Bigtable. We make it very simple when we say, like, hey, it's a fast and flexible store at scale, very simplistic. There's a lot of detail behind it, right? To start off, Google started with scale, and it had apps at web scale serving billions of users, and you need databases and storage systems that actually scale. Bigtable was one of the systems that helped Google scale. It was even called out in Sundar's post in the morning on how Bigtable is used for a lot of services that run within Google. So we're very proud of the service, and I would like to talk a little bit more about it. So I started off by saying it's fast and it's flexible. It's getting faster. It's now actually able to get under 1 millisecond reads. And it actually does fast reads and writes. That's another specialty of it. It doesn't discriminate. You can do fast reads, fast writes. And you can also do them at a good price point and cost. That's important. When you want to build big apps, you can build big apps. But if the price keeps going up, then what's the point, right? You want a system that scales and scales at the right price. So that's the fast element of it. And Bigtable is flexible. It's amazing, the versatility of Bigtable, right? I mean, you can start with like 1 replica, you can go up to 24 replicas. You can start with a zonal situation, and you can go to a regional situation, you can go to a multi-regional situation. You can have 1 column, or you can have 10,000 columns. You can have HDD or SSD. You can have a tiered storage on them if you want. It's very flexible. What does it mean for you, though? Well, what it means is you can bring your workloads, and then you can configure the Bigtable configuration to really match your workloads to get the best price, performance, and cost for you, right? So that's the fast and flexibility of Bigtable. It's getting very strong recently in real-time intelligence stuff. So it can take in all your data, your streaming data, and actually convert it into something of intelligent analytical information that can come out of it, right? We are launching really strong systems like this, features like distributed counters, continuous materialized views, reverse ETL from BigQuery, and asynchronous secondary indices. So it is able to like process and munch on the data while not impacting your friend or application traffic. It can do a bunch of processing and make something useful out of it. So it's getting pretty exciting in that space as well. It's large and huge. 7 billion queries per second is the peak query QPS that it can serve at this point. It's very popular for users like Cassandra and HBase. A lot of them actually, since the NoSQL tag is there, a lot of them actually come and use Bigtable, and they're very successful. And we also have good toolings to let you migrate and move things seamlessly. All right, so let's talk about scale. I'm going to brush through this because sometimes we get very jaded with these numbers, and even we don't understand what's going on sometimes. So Bigtable can get really big, right? And it doesn't need to be big. You can start small, like I said, very flexible. So it can get very big, though. You can go to like an exabyte size table, single table. We're not talking about all the services all around the world, but just in one table. You can serve 1.6 quadrillion rows. Right? We had to look it up. It's a million billion, right? If you didn't know what a quadrillion was. And a single table can serve 250 million QPS, right? So this is truly a big table, right? Keyword being big, right? The flexibility part of it that I mentioned before essentially means that it is very versatile and used across many use cases and across many industries. We can't go over all of them, but I do want to call out something that is hot right now, ML feature stores. You want a fast system that can serve your features, you want a fast system that can process your features, and you want a fast system that can synchronize features across like things like BigQuery. And Bigtable is like a very good shop for having your ML feature store workloads. Bigtable is really good with like writes. Like I told you, it doesn't discriminate. It's fast for reads, fast for writes. So it's also pretty good with like clickstream data, seller analytics, transaction histories, vehicle telemetry, lots of time series database. And we can talk more about these things as we get along. All right. So, but that's all about what is Bigtable. But we are here to talk about what's new in Bigtable, right? Pretty exciting, actually, this year, right? We are announcing this year Bigtable in-memory tier, right? We're very excited. And I want to take a step back and say what it is. And sometimes, it's hard to explain it. So I'll try my best, and we'll go over a couple of slides over here. Bigtable always had disaggregated storage and compute. What that means is like your storage can increase while your compute need not increase, so you pay only for that compute, or your compute can increase and storage can stay the same. We've essentially done that for your memory and compute right now. So we can do certain special things with your memory, and it can stay where it is, and your compute can grow up and down based on your needs. But what does it give you? Let's start with what does it give you? Well, it'll give you fast and cheap row lookups. And it does that at a high throughput all at the same time. Right? That sounds great already, right? But you can always come back and say, like, I've already solved this, or I can do this by putting some other system in front of databases, like putting a cache system in front of it and all of that. But well, we want to say why, right? You want to deal with one system, one API, don't have to deal with like two systems with two different bills, controlling the ACLs between two systems. This is just Bigtable API. In fact, your application will not change when you use the in-memory tier feature. You enable it on the database, and then your application will just get the benefits of it, and you're not dealing with multiple systems, multiple APIs whatsoever. So that is great. That's great. And some people might come back and say, but you know what? We might have solved it internally. We have tried kind of like, put like an API, a library in front of our database access, and it'll automatically and seamlessly move, or like, figure out the data that is cached versus not. But we do more. It's not, we actually maintain consistency between what is there in our memory and what is there in the database transactional server, which means you don't have to worry about like, is it stale? Is the data expired? Do I need to worry about what result I get from like reading from memory versus reading from the direct transactional database? None of that. It is just Bigtable, but accelerated. Right? We maintain the synchronization to an extent that even if you're getting a write from a replica, the replicated write will also update itself in memory and give you the right updated data. Right? So pretty exciting feature. We're very excited about it. Oh, the wrong direction. Next slide. Okay, but what does it mean in terms of numbers? I just told you it's fast, it's cheap, it's high throughput. Let's linger on that a little bit. It can make row lookups up to 10x cheaper, and that is not a mistake. That is true. There are some limitations on what kind of row lookups and all of that, but it's pretty wide, and it makes it up to 10x cheaper if you're able to hit the row in the cache, in the in-memory tier. It can make QPS of a single row go up to 120K QPS. Think about that for a second, right? And when we're doing horizontally distributed systems, we always used to worry about, oh my God, if I have a hot row, you must have heard about hot row many times in your designs, and you'd have said, oh, if I have a hot row which I'm reading quite a bit, I need to worry about it, right? Not anymore. If you're reading a hot row and in-memory tier in Bigtable, you can go up to 120K QPS. And I think we can do more. We just didn't want to call it out right now. And you'll get latency, which is a sub-millisecond latency with this tier. So exciting, exciting days ahead. I want to step back a little bit, though. I want to step back. We talked about in-memory tier on its own, but we really didn't put it in perspective with all the things that Bigtable brings together for the hybrid architecture, right? This is the thing that you usually see in a typical database. Not even this, actually, because we have disaggregated storage and compute. So our compute is in green and storage is in blue. And you have standard access. You can read from your Bigtable node, and it'll access data from our SSD, and it's going to get back data for you. That's great. But look, there's more. We've already introduced tiered storage, which means that you can seamlessly move data that is not so hot into our HDD storage, and it'll automatically manage what is hot, what is not, and move data from SSD to HDD. Great. That's already a step above, right? The first step is disaggregation of storage and compute. The second step is we also provide HDD SSD tiering, which is automatic. So that's already 2 steps beyond what typically databases can do. But we launched Data Boost 2 years ago, right? This is an excellent feature where you can actually have a lot of analytical programs and jobs read directly from your file system and not affect and impact your direct transactional database. So you can run your analytical queries without having to worry about what impact it's going to have on your operational and low latency requiring requests. Now, this year, what we launched is RAM and in-memory tier. What this does is somewhat similar, right? I mean, you can actually now scale pretty well independent of like the actual database compute. It'll do a cache hit. It'll manage the data in our servers and memory and disaggregate them and keep it consistent. So this is the broad picture of the kind of innovation that Bigtable has brought into the hybrid architecture. So that's great. How do you try this now? Well, you can try this in our new Enterprise Plus edition that we are launching today. We are able to bring in a lot of new features into Enterprise Plus, which Enterprise Plus setup enables for us. We are able to do cluster level automatic backups. We are able to do Data Boost Plus. I talked about Data Boost. It used to be able to only read from SSD files directly, but now Data Boost Plus is able to read from SSD, HDD, tiered SSD and HDD, and also have Data Boost work with SQL queries. So this is a nice big bump for that feature. And we're also increasing a bunch of limits, like SSD tier storage limits to like 64 terabytes per node. We're also increasing our backups to like more than 1 year, and bringing a bunch of developer-friendly features like query taxonomy into the Enterprise Plus tier. You can try out Enterprise Plus edition today. There's actually a lot more than this that we're launching, right? We talked about a few things, but the velocity has been amazing. Bigtable team has launched quite a few things which are new. So we can't go through all of this, but maybe let me try to like categorize them a little bit, right? Writes are great in Bigtable. So time series, which is a subset of the heavy write use cases, they use Bigtable quite a bit. Windowing functions, we launched that so that it makes it easier for folks who are using Bigtable as a time series store. Card telemetry is also popular, which is a combination of like geo and time series, right? So we launched 70 plus functions in 70 plus geospatial query operators to help with that use case. We're pretty proud of that. Continuous materialized views, I talked about it, how you can take streams of data and make something useful out of it and give operational insights. Continuous materialized views can also be used to create asynchronous secondary indices. So, again, things that have been pretty popularized in Bigtable, we have them now in Bigtable. And we have other support like PubSub subscriptions, where you can automatically have a PubSub topic be synchronized into Bigtable, and protobuf support. That's a lot. Thank you for hanging in there. But there's more. The one last thing, I guess, which is we're offering a free trial on Bigtable. Now you can actually use Bigtable for 10 days with an option to carry on for 90 days. And it's not a puny free tier either, right? You're getting 500 gigs of data that you can play around with, and you get a single node while we're at there. So that's the journey of Bigtable. Let's move on to Firestore. That's a lot to talk about, so let's move on to Firestore. Firestore is our enterprise JSON database at scale. It still surprises me. Firestore really surprises me because not only do you have Firestore being used for like enterprise applications and enterprise workloads, and it also supports some of the most complicated features that you can build on a distributed system at scale, right? It has finance availability, it has multi-regionality, you can do multi-region commits, multi-region transaction, almost asset semantics, and it does all of this, and at the same time, it is also used quite a bit actually for also a little bit smaller apps that people make in weekends, and it can run all of these apps sometimes in the free tier, which is quite generous. So it's got a wide spectrum, and that's the thing that keeps me surprised all the time, right? So the complex features, finance availability, enterprise security, enterprise governance, while at the same time being extremely developer friendly, that people are able to make weekend apps and run them and try them out. This is crucial though in the AI era, being able to like try out a serverless database like Firestore, so that you can create a database instantly, try it out, don't like, change the schema, then again update, delete, and create a new one, almost like you're creating a file, but it's actually a database. This thing, right, is crucial. It's crucial, especially in the agentic style of development, because your agents are kind of the same thing like developers, right? We're all trying to like, create something, don't like it, rechange it, right? So this is going to play very well into the agentic era, and Firestore has a lot of potential over here. We're pretty excited about that. We also have launched last year at this very venue at Next, Firestore with MongoDB compatibility. We're going to talk a little bit more about that as well. This is all about choice. If you have been using MongoDB, then you can use MongoDB API and Firestore strings together, and I think that's a great thing. It's no surprise, the numbers you're looking on the slide over there, right? Having 2 billion users, end users being served by apps that are powered by Firestore, having 750,000 developers who are active on Firestore, this tells you how developer-friendly and versatile of a database this is. And the power of JSON schemas, let's not forget about it. It's a NoSQL talk, right? Flexibility, that's important. It has a lot of common use cases. It has retail, mobile, gaming, content management. And I'm running a little bit low on time, but the important thing is like it can do asset-like transactions and have like multi-region availability and so on. So that's why retail, that's why mobile, and that's why content management, which is flexible, right? Mobile is actually another strength of Firestore. Mobile is great in Firestore because it can do offline reads, it can have offline synchronization, and all those goodies, good stuff in client SDKs, which are not usually available in other databases. So, well, what's new? We are making the developer experience even better. We have integrated Firestore. It's one of the first databases that came into Google AI Studio. So you can kind of create end-to-end apps right now, kind of basically wipe them if you want to. We have invested in our remote MCP services, and we have invested in the skills for them so that you can use Firestore with third-party tools like Claude Code, and Cursor. And we even made it even friendlier on the studio, on the Firestore Studio itself, where you can literally talk to your database and query the data in natural language. We're launching Firestore Native Edition right now in Enterprise. Sorry, we are launching Firestore Native in Enterprise Edition. We launched Enterprise Edition last year with Firestore with MongoDB compatibility. Now we are launching Firestore native APIs in Enterprise Edition. And we have added a ton of query power over here. I can't talk about all of this thing, but a lot of power has been added, is a short way to put it. You get pipeline operations in Firestore right now, which can do things like joins, aggregations, bulk edits. This is good stuff. And we've also invested in geospatial, which is great because Firestore is good with mobile apps. And developer friendliness is always on top of our mind. So usage insights and integration with Knowledge Catalog is also coming into the Enterprise Edition with our Firestore native API. More exciting is we are bringing in full text search, both in the Firestore with MongoDB edition and in the Firestore native APIs. And this brings in some of the goodness of Google and experience of Google, right? It handles things like phonemes, synonyms, spell correction based on your language, and so on. So it's truly differentiated, and we are excited about it. It also is consistent. You don't have to wait for your search index to build, and then your full text search is going to respond. The minute you have some data in, it's going to respond back on the full text search. Pretty cool, I think. As I told you, I promised you I was going to talk about MongoDB compatibility. We launched it last year in preview, and now we have it in GA. You can leverage your familiarity and the strengths of Firestore all together with this. And we have invested and done more over here. I already talked about full text search with all the special sauce of Google's expertise. Now, on top of that, we also launched change streams, and now so that you can follow along with your data edits and synchronize it maybe, and do ETLs to things like BigQuery, for example. You can do bulk data lifecycle management, like dropping collections, doing TTLs on collections, which is also a heavily requested feature. And we have support for large docs up to 16 MB, right? So this is getting better and better. We've been adding a lot of compatible stages for MongoDB on Firestore. We have up to 200 plus stages and operators right now. So this has gotten to a very strong point. I talked again about mobile, Firestore being the database of choice for mobile. That is true. I mean, you basically can have you can have bad connectivity and still keep your apps running well because Firestore clients SDKs can handle the disconnects and can handle the synchronization of the data between server updates and so on. So I think it's pretty fascinating. So if you have mobile apps that are looking for a home, then Firestore is a great place. With that, let me invite Chethana, Director of Engineering from Palo Alto Networks, and she's going to walk over the challenges they're solving and how they're using NoSQL portfolio of Google GCP in their day-to-day. Thank you, everyone. Thank you.
Okay. Thank you, Vaibhav and Phani, for giving an overview of the NoSQL databases and the latest capabilities that are getting added. The next natural step is for us to understand how these databases perform when they are run against massive production datasets and workloads. Hi, I'm Chethana Savalgi, Director of Software Engineering, Prisma SD-WAN solution from Palo Alto Networks. I'm here and excited to present you some of the use cases that we have at Palo Alto Networks, where we have deployed the NoSQL databases at scale to address some of our critical business requirements. Quick introduction about Palo Alto Networks, the global AI cybersecurity leader with the mission to be the partner of choice in protecting our digital ways of life. The Palo Alto Networks offers a portfolio of cybersecurity solutions covering network, AI, and the entire enterprise network systems. We are trusted by 75,000 customers globally, over 150 odd countries. The first use case that we will see is the data analytics platform from Prisma SD-WAN solution, and we have had a huge success with Firestore database being the prime database in the entire solution. Quick introduction to Prisma SD-WAN. Prisma SD-WAN is a product offered by Palo Alto Networks, and it covers completely or works on the principles of software-defined networking principles, where it offers the network management and optimization of the enterprise or the WAN area networks. So the solution is comprising of a centralized cloud-hosted solution to which the on-premise or the appliances connect and share their networking health-related metrics such as jitter, packet loss, or the latency that is seen in real time. The controller has the complete visibility of the network. The controller is able to ensure, or the entire solution is able to ensure, the app awareness is built into the system, and app-aware traffic routing happens in real time. The entire solution offers also a centralized policy configuration and QoS metrics, which will enhance the distribution of the configurations at scale without manual interventions. The core feature of the data platform is the data analytics platform, which is basically offering the real-time insights into the network metrics. It ensures the entire health of the network is visualized, provides the APIs, standard SDK APIs, and the visualization, and also offers the pre-canned, pre-scheduled reports, which are available as which the customers can download or access through the API framework. These metrics or these reports cover extensive network health metrics such as the egress and egress utilization, and the application utilization, and the circuit utilization as well. So the entire platform offers features which ensure that the network operators are looking into these metrics and doing the proactive network management instead of the reactive troubleshooting. So we were at a situation of re-platforming the entire data analytics platform. This is mainly because of the extensively distributed architecture that we had. We had the complete solution, the data lake, petabytes of data lake hosted on the Google BigQuery system, whereas our operational data, which defined the reports and the schedules, customization that we have done for the customers, were all residing on a self-hosted Mongo cluster outside of the GCP platform. The objective of this architectural transformation was to ensure the high operational overhead of moving the data from across the cloud distributed platforms was reduced, operational cost was reduced, and we simplified, upgraded the entire architecture. With this objectives in mind, we chose Firestore as our natural or a compatible database, and the architectural objective was not to change the database or reinvent the entire data schema and the models. With this, Firestore was definitely a database of choice for us, and it helped us to have the continuity with the production data sets that we had already with the document alignment model. And along with this, we also got the logical continuity of the application that we could leverage. The zero infrastructure management was a huge benefit in this case because we were investing heavily in the engineering and operational overhead in managing the entire Google Cloud or the self-managed databases, and Google Cloud offered us the completely managed a platform, which saved a lot of engineering efforts in the operational cost also. With a unified architecture, we could get both operational data and the analytics data onto the same platform. We have the analytical warehouse hosting, which is capable of running the massive analytical queries, was already hosted on the Google BigQuery, and operational store, Google Firestore, offered us the entire metadata and the templates and the customization that was needed to run the reports. So we use Firestore in the enterprise edition in the Mongo compatibility mode, and Firestore offers all the critical metadata needed for us to run the analytical queries, which includes the report definitions, schedules at which we have to execute, and the customization. And important aspect of this data storage is also the status tracking. We are able to efficiently track the status, understand the amount of processing that has happened, latency that has taken, and also any kind of resubmission or error status that are found during the execution are also getting alerted. So with this migration to Firestore, we could easily deploy to 20 plus or GCP regions, and the cost optimization was close to 64%. Alerting and monitoring has been of great benefit in this case, whereas the entire platform offers automatic latency and some of the critical metrics such as the read and write latencies and active connections, number of active connections that are held to the database. So in summary, I would like to say that definitely this migration has been of great benefit to the product, and it is a low risk transition. We were able to retain our intellectual property without much cost efforts in transferring the entire data to the GCP platform. With the additional benefits of serverless operations, we are able to save a good amount of engineering and operational costs and efforts as well. I'll move on to the next important migration story that we have had at Palo Alto Networks, that is with Bigtable. The advanced wildfire is a solution offered by Palo Alto Networks. It is the largest cloud-hosted malware protection engine. The solution analyzes over 1 billion samples every month, and it is doing all the processing using the inline ML algorithms, static and dynamic data pattern analysis. And all of these are extremely important for customers and the Palo Alto ecosystem of products which rely on the verdicts provided by the AWF framework to either allow or deny the samples that are found in the system. And it also helps to address or protect the environments from sophisticated threats. GVS is a core component within AWF, and this has the responsibility of ensuring the samples are analyzed, the metadata, critical metadata is retrieved and stored into the core database, which is a NoSQL database in this case. So challenges with Cassandra. So the solution had Cassandra as the primary database, and there were multiple challenges with the Cassandra system. The topmost being the performance issues. We had high latency and occasional timeouts as well that were happening with high CPU usage and often triggered by the backend compaction processes. The compaction process is an important database management activities where it is compressing the existing tables into a single table for optimal reads. While all these operations are getting performed, it takes a load on the overall latency that the system is offering. The maintainability of Cassandra and ensuring the database is performant was taking a lot more effort from the engineering side, as it was all has to be done manually. To overcome this issue, the Cassandra clusters were funded with additional infra. We had scaled them from 5 node to 12 node cluster, and it did result in some kind of increase in the overall maintenance cost of the clusters. Apart from this, the replication effort were also very high. Being a multi-cloud environment where the solution is offered, the replication, manual replications, we had to also write the custom pipelines to ensure the data is in sync across all the networks. The Bigtable migration was definitely a game changer here with the multi-phased approach with Bigtable. We ran into one-time migration with curated data integration checks, followed by a stage where the dual writes were happening to Cassandra as well as Bigtable. Later, in phased manner, the read workloads were directed to completely to Bigtable, and finally, it was the Cassandra cluster were decommissioned. With this, we could see a consistent increase in the latency overall and 50% reduction in the infrastructure cost. The production issues, main highlight of this architectural journey and the improvement was that 50% of the issues were reduced by, or 90% of the issues were completely reduced, which are resulting due to the high latency challenges. Advanced Wildfire being a very complex system, it has multiple NoSQL databases, instances, use cases within it. Memorystore is yet another one wherein we use in Advanced Wildfire. As I mentioned earlier, Advanced Wildfire uses millions of records or scans millions of records every day to ensure the data or the samples are processed or samples are analyzed effectively. So running a full-fledged scan for each of the sample or known pattern would result in the bottleneck in the system. To avoid the performance latencies, we use the performance critical caching layer in the Memorystore layer. So all the critical authenticators and high velocity authenticators, lookup signatures are all cached so that the engine can quickly do the lookups and provide the verdicts on time. The second use case is the microservices as a shared memory for the microservices. So the entire pattern analysis is a complex process in the security world. It is usually the functionality is distributed by multiple microservices, and the state machine is a multi process, and the state machine and the status of these interim results are to be hosted and shared across the microservices. So this critical metadata and the seamless processing is all done through Memorystore, and it is one of the strongest use cases that we have in the wildfire use case. Advanced DNS security is another component from Palo Alto Networks where DNS records are at internet scale. DNS records, the DNS signatures and the resource records have to be processed, and we were in need of low latency data tier which could offer good amount of data scale requirements, and Memorystore has proven to be a good use case and a perfect match for this requirement. The additional feature that we had here is to migrate from Redis instances to the Walkie instance migrations. So the Walkie migration was needed, critical for us to ensure the data is distributed and there is no single point of failure as we had seen in case of the Redis instances. The entire journey of migrating to Walkie was extremely beneficial for the Palo Alto Networks engineering team, and we got engaged with the Memorystore engineering team, and with their expertise in the architectural design reviews and the production support, it was a good experience, and the team here at Palo Alto Network was able to move with confidence and clarity and achieve the milestones that we wanted to achieve. With this, I'll come to the end of the use cases. I hope all these use cases provided you the blueprint that you are looking for your architectural journey and the improvement with your products. Thank you. I'll hand it over to Vaibhav.
Thank you, Chethana. Again, thank you, Chethana. Hopefully, you were able to see how Palo Alto Networks is using not just Bigtable or Memorystore, but even the portfolio of database services, including Firestore, for SD-WAN use case, wildfire use cases. So it's very encouraging for us to see how our customers are being successful using our cloud-native database services. Now, I'll just like to run through. There's an exciting list of session lineup which we have. For Bigtable, we have sessions where where Anthropic is presenting with us on Friday. This is about a prompt completion workload which is running at extreme scale. They are other use cases which will be shared in some of the other breakout, as well as there's another session where we are covering the automotive AI use case, something which Phani was saying, the vehicle telemetry use cases. In case of Firestore, we have MLB speaking about their journey with the MongoDB compatibility. And on Memorystore, we are going to double-click and talk about Valkey 9. And Snap will be presenting how they are leveraging Valkey at extreme scale, especially Memorystore for Valkey, and how their journey has been in terms of migrating a lot of their workloads to Memorystore. So thank you everyone for your time and attention. Please take some time to fill the feedback form, give us the feedback. This is how we know what kind of content we prepare. And the presenters will be right here after the session to answer any questions you may have. Thank you so much.